Good morning, ladies and gentlemen. Today we're going to look at inequalities, and I hope you're ready to take notes. So, in maths, we focus a lot on equal signs, but in reality, circumstances pop up requiring inequality signs really quite a lot. For example, I could say that the bridge will hold as long as there are less than 200 tons. I could say that in order for me to buy a house in town, I would need $500,000 of money. Now that means that anything above that would be fine. I'd love to win the lottery getting more than $500,000, but anything less than that won't be okay. However, this second bar here means that exactly $500,000 is okay. Note there's no equal sign here, so the tonnage on the bridge has to be strictly less than 200. 200 is not okay, it must be under. Alright, so essentially these four signs here can be treated as alternatives to an equal sign. And we use them as alternatives to an equal sign in an equation with a couple of minor exceptions in the way we use them. So, if I were to solve and show the solution graphically to these, there are a couple of steps to go through. Firstly is get x by itself. Now, that we're quite used to doing, and by looking at this you can probably see where the solution point will be, I guess. Take 2 from both sides. 3x is less than 6. X is less than 2. Okay, so clearly I've taken 2, and I actually forgot to write the sign step here, but we're dividing by 3. What that means is that any number under 2 is an acceptable solution to this inequality. So for example, the most obvious one to pick is 1. 3 lots of 1 plus 2 is indeed less than 8. However, 2 is not an allowable solution, because 3 lots of 2 plus 2 is not less than 8. 3 lots of 2 plus 2 is 8, which means that it's not less than. However, 3 lots of 1.999 plus 2 is less than 8. So the question then becomes, how do we show all the possible values for x graphically? And graphically meaning some way you can look at it and see the answer without having to understand, well, exactly what this symbol means. And the way we do this in maths is we draw a quick number line. We say this number line represents x, so we put an x there. We then typically put 0 in there. And then we put the key point that we want to talk about. And here the key point is 2. And I'm going to say that anything less than 2 is an acceptable solution. So anything that way of 2 is acceptable. Note how this dot here is not coloured in, it's open. Open represents that it does not include 2, it is anything less than 2. So by leaving that dot open, I'm saying that 2 here is not a solution, but anything less than 2 is. Alright? So when it says solve a linear equality and show graphically, it means solve it like you would a linear equation, and then show it on a number line. Alright. That seemed easy, didn't it? It gets a little harder. Alright, let's look at another one. Now, same as again, you want to unwrap x, get x by itself. Take 4 from both sides, minus 3x is greater than or equal to 9. So far, so good. Then we divide both sides by minus 3. X is greater than or equal to minus 3. Now, let's just think about whether this would work or not. What we're saying is here is that any number bigger than or equal to minus 3 would work. So a number bigger than or equal to minus 3 would be, let's pretend x is equal to minus 2. That's bigger than minus 3, remember. Let's substitute that into the equation and see if we get a correct solution. Alright? 4 minus 3 lots of minus 2 is greater than or equal to 13? Well, minus 3 times minus 2 is positive 6. Really, this is reading as 4 plus 6 is greater than or equal to 13. Which is clearly not. 4 plus 6 is 10. Not bigger than 13. So what's gone wrong here? Because this isn't providing us with a set of solutions that actually make sense in the original equation. Well, let's take an even simpler example. Actually, no, the one we've got here is pretty simple. Take a look at this stage here. Minus 3x is greater than or equal to 9. That's asking what number requires to go into x to be bigger than or equal to 9. Now, we've got one negative, so to get something bigger than 9, we're going to need another negative from x. So, for example, x equals minus 2 won't work because that will get us positive 6. X equals minus 3 will work, because that gets us minus 3 times minus 3 is positive 9. X equals minus 4 will work. So really, we're looking for any number that is less than or equal to minus 3. Because we know that minus 3 works, minus 4 works, minus 5 works, etc. But 2 and 1 don't. So note the difference between this, that makes sense, and we can try solving back into the original equation, it will work, and this, which gave us solutions that weren't right. The only difference between the two is that the sign has been flipped. This here is the other way around to that. Right. The first and most important trick of using linear inequalities is that when you multiply or divide by a negative, you must flip the sign. Notice here, we divided by a negative, and that changed the sign of both sides. If you change the sign of both sides, you need to flip the sign around. Alright? Same as if we'd multiplied by a negative, we'd have to do that as well. It may be that in a long, complicated equation, you have to flip the sign several times, if you're multiplying by a negative several times. Alright? Now, on a number line, whoop, okay, we're getting a big highlighted number line. Doesn't matter. X, 0. Our point of interest is minus 3. I am saying that it's anything below or equal to minus 3. And because it's equal to minus 3, notice how I've coloured in the dot. The way I remember it is, there's more coloured in here, so there's more coloured in there. More ink, more ink. Alright. One final one. Take 3x from both sides. I want to get all the x's by themselves. 2 is greater than 3x take 4. Note I haven't flipped it because I haven't multiplied or divided by a negative. Add 4 to both sides. 6 is greater than 3x. Divide both sides by 3. 2 is greater than x. Now, because we're used to seeing x on the side, some people might just be comfortable doing this, writing, well, x is greater than 2. Whoa, sorry. Just flipping it round. But remember, if you just flip it round, it actually changes the meaning. This is saying that x must be less than 2. Whereas over here, if you change the 2 and the x around, you completely change the meaning. So if you do want to put x on the left-hand side, that's fine. You must flip the sign as well. It must go to x is less than 2. Alright? So, working with linear inequalities, solving equations, is normal, except when multiplying and divided by a negative, switch the sign. When switching sides, switch the sign as well. Can you please solve and graph the following equation in OneNote? Thank you very much.